Hello class, these are our notes for section 3.8 in Algebra 2, cube and cube root functions. So first we're looking at the cube parent function, and that means y equals x to the third power. So in class we made a table, and for our xy table, I gave students the values of -2, -1, 0, 1, and 2. So these are pretty good basic numbers to start out with for x if you are not sure what a graph is doing. To figure out our y value, we would just put the numbers in for x. So first we would do -2 to the third power. That's -2 times -2 times -2, that's -8. Then -1 to the third power. Again, negative times negative times negative is going to be a negative. 1 to the third is just 1. 0 to the third, which is just 0. 1 to the third, which is just 1, and 2 to the third, which is 8. So you know what, I said 0, but I put a 3 down for some reason. So this is what we graphed. So let's go ahead and graph -2 for x and down 8 for y. -1, -1, 0, 0, 1, 1, 2, 8. So we get this really interesting cubic looking function. And you've probably seen it before. So just to kind of connect this back to things we've already learned when we looked at our polynomial chapter, x cubed could look like this, it could look like this. Because it's a positive x cubed, it's going up from left to right, which we clearly see in our graph. And then the other kind of interesting thing to point out here is that, remember, if we had y equals x to first power, that's where our function crossed. If we had a y equals x squared, we had a bounce. If we had y equals x cubed, we had like this weird cross but flatten. And that's the kind of behavior we've got at our graph. So I think it's just always good to point out those kinds of things because we're reviewing all along. So for domain here, I want to think about numbers that I can have for x. So if I look at the table here, I can see that I was able to use numbers that were negative, I was able to use 0, I was able to use positives. So other things to consider are, can we put fractions in for x? Can I put decimals in for x? And it's true, we can put anything in there for x and raise it to the third power. So my domain is going to be all real numbers. And remember, the symbol for all real numbers is that fancy looking R with the double line. When I think about my range, it's the y, so now I'm looking at what kind of numbers can we get out of our function, and that would be the -8, -1, 0, 1, 8. So we're still looking at being able to get out negatives, 0, and positives. And we could still, if I take a fraction, like say 1/2, and I raise it to the third power, I'm going to get another fraction, right? Or if I plug in a decimal, I'll get another decimal most likely. So this is going to be all real numbers as well. So I'm going to go ahead and scroll down to the next one and to do our cube root. So remember, x cubed and cube root are inverses, because if I have an x cubed and then I take a cube root, I'm back to x. So because they're inverses, their x's and y's are swapped. And that's something that we're going to talk about later as the year goes on. So for now, if they're inverses, our x's and y's are swapped. So that means I'm literally going to take my y row, -8, -1, 0, 1, 8, and I'm going to write that for the x. And then for the y row, I'm going to use the x row, -1, -2, -1, 0, 1, 2. And this is going to actually reflect my graph along this line, y equals x. All right, so when my x is -8, my y is -2. -1 is still -1, 0, 0, 1, 1, and then 8, 2. So there's really only a couple points that are different, huh? And it really does look like it's been reflected over that line. So if I had these graphed together and I folded them on that purple line that I made, they would match up. So domain here is going to be all real numbers. We're still putting in negatives, 0, positives. We could put in decimals or fractions and take the cube root, and the range is still going to be all real numbers as well. So moving on, we're going to talk about number of solutions. So if I have y equals x cubed, or if I had y equals x squared, I'm going to get just one solution today. And we kind of saw that in some of the activities that we did. If I have x cubed equals -27, one number will work. That's going to be a -3. If I have x cubed equals +27, the only answer would be x equals +3. So I can't switch my negatives and positives around. I can't get a plus or minus answer for this. If I take a -3 and raise it to the third power, I don't get a 27. It's always going to be negative. So they're always going to have one solution, and that's for y equals x cubed or y equals the cube root of x. These are a lot easier to work with today. When we had y equals x squared, we could get 0 solutions or 1 or 2. So it just kind of depended. If I had x squared equal to a positive, when I take my square root, I get a plus or minus 2. If I had x squared equal to a negative, remember we had no solution. That's that 0 with a line through it. And if I have something like x squared equals 0 and I solve it, I just get x equals 0. That's one solution. So for my square root graph, those were interesting. I had either 0 solution or 1. So if I had square root of x equal 1, square both sides, x is equal to a positive 1 as well. The second one, though, when I have a square root equal to a negative, that's when I have no solution. So I can only solve it when I have positive or 0, and that's when we get one solution. So for Check Your Understanding, we're continuing to practice this, right? Where I give you something and I tell you to estimate it from a graph. So you're going to have to be able to do this on your test. You're not going to get a calculator. So I'm using y equals cube root of x to estimate cube root of x equals -4. So I think students are having trouble figuring out, well, does x equal -4 or does y equal -4? So what I notice here is that both of these have a cube root of x. One has a y, one has a -4. So that means I'm going to let y equal -4 and find the x. So let's go on our y-axis to -4. To follow that across to my function, it hits right here, kind of right after the -60. So maybe I estimate and I say x is about -62. I'm not really sure, but that could be my guess. We'll come back to that in a minute. So solving cube and cube root equations algebraically. So it's almost the same as solving square and square root equations. We're going to isolate. And then instead of taking a square or a square root, we're going to take a cube or a cube root. As the domain and range are all real numbers, there should only be one solution, which means we don't have to worry about extraneous solutions. So the solving is going to be a little bit easier. So Check Your Understanding number 1. We did these together in class because they did a lot of practice on their own. But for number 1, it says cube root of x equals -4. We want to solve algebraically. That means we're going to raise both sides to the third power, and that would mean x equals -64. So if you remember on our last page, we estimated -62. So our estimate was -62. So they were pretty close. It's hard to get an accurate number just looking on the graph. So same thing when we grade a test or quiz, we're going to be watching for you just to be close. Solve the cube root of x equals 3.5. So that means I'm going to go back to this graph, and now instead of finding -4, I want to look for -3.5. So 3.5 would be about here. I need a different color. 3.5. So about here, so maybe -50, -48, I'm not really sure. I'm just going to make up a number. I can tell what two it's between. So my estimate is going to be, oh sorry, it needs to be a positive 48 because I need to go for positive 3.5. So that's going to be in here. So it looks like a little bit less than halfway. Halfway would be 45, so maybe I need it to be even smaller. Maybe like 43. And again, this is just an estimate. We're not expecting perfection. Okay, now I want to go ahead and solve it. I totally did this in the wrong order, didn't I? It said to solve and then check the graph. And I want to cube both sides. I know on your test you're going to be doing it the opposite way around, though. You're going to be looking at the graph. And then if I work out 3.5 to the third power times 3.5. I got a baby calculator here, so it's taking a while. 3.5 and a while because I put the wrong number in. I get 42.875. Wow, that's actually really close. And all I knew was a little bit less than 45, right? Okay, so pretty close again. So this is our answer. The graph checks out. They look like they're equal. So for the solving, remember, we're always trying to isolate our root. So on A, we would subtract 6 on both sides. And then I have the cube root of t equals negative 6. So once I have the cube root by itself, I need to raise both sides to the third power. So a third power and a third root will cancel. And the root part is gone as well. It's not like it only cancels the 3 and you still have a square root left behind. It's just t now. On the other side, negative 6 to the third power is negative 216. Next one, I also want to raise both sides to the third power. So that's going to be t minus 4. And on the other side, 10 times 10 times 10 is going to be 1,000. Add 4 on both sides, and we have t equals 1,004. All right, for C, I'm noticing both sides are negative. So the first thing I'm going to do is divide both sides by negative 1. So now I have positive 20, and I have the positive cube root of b. To get rid of a cube root, we're going to raise both sides to the third power. So 20 times 20 times 20 is going to be 8,000 equals b. All right, last one. People really wanted to add 9 on both sides in class, but we talked about how the 9 was inside that radical sign, so we cannot do that first. So your first step is going to be to get rid of the cube root by raising both sides to the third power. And now I just have 2m cubed minus 9 equals, and 3 to the third power, 3 times 3 times 3 is going to be 27. So now we can work on getting m cubed by itself. Right? This one's tricky because we have a cube and a cube root. So let's go ahead and add 9 on both sides. 2m to the third power equals 36. Divide both sides by 2. M to the third equals 18. And then because I have a third power to get rid of, I'm going to take a third root on both sides. And remember, with cube roots, it's just always one answer. We don't have to worry about absolute value or plus or minus. My answer is just going to be the cube root of 18. There's nothing I can do to simplify that. So big ideas today are just solving cubes and cube root equations. So I realize we didn't look at any equations that have x cubed here on notes, but we will definitely look at a bunch of those together in class. Estimating things off the graph still is a really big skill that we need to work on. Make sure you understand those. You're going to see those on a test and quiz. And as always, if you have questions, make sure you ask.